Hello everyone, welcome back to my channel. In this video we are mainly gonna solve some physics problem. So the problem in this video might be a little bit challenging, but don't worry because I am going to solve them step by step. But still, pause the video before each problem and think about them by yourself. So the first problem says a car with initial velocity of 15 meters per second drives up a hill of 120 meters. The acceleration is negative 0.6 meters per second squared. How long does it take for the car to reach the top? So here are at least 3 steps that I usually do when I am solving a problem. So the first one is label all information you know and think about what you need to solve, right? So what is a question asking for, and then think one formula that you can use to solve your problem. So first of all, in this problem, I know the initial velocity, I know the displacement, I know the acceleration, and how long. So the question is asking me to solve for time, right? So the first formula that popped in my mind is this one. So now I have a formula, so I'm just gonna plug in the numbers. So 120. So I'm not gonna write unit right now because it's just a little bit messy to write. But I will write the unit for my answer. 15t. So now you see there are 2t, so it might be a little bit hard to solve, but this is just a quadratic formula, right? Quadratic function. So you can factor to solve for the equation, right? So factor. So what I'm gonna do is I'm gonna move the 120 to this side. So 0 is equal to, and I'm gonna simplify this part. So this is equal to negative 0.3. As 0 is equal to negative 0.3t squared plus 15t minus 120, right? And then I'm going to multiply the whole equation by 10. So negative 3t squared plus 115t minus 1200 is equal to 0. Now you can just factor this this formula, right? So negative 3, so 1 3, and here is 110. So I can use what I can use is here it can be a positive 1, and then here can be a negative 1, and here can be negative, here can be positive. Positive times positive is, negative times negative is positive, and positive times positive is also positive, right? So we are running out of space right now. It's okay. Alright, so 0 is equal to t minus 10 in parentheses, and here is negative 3t minus plus 120, right? So now we are just gonna solve for t. So because the whole equation is equal to t, so t minus 10 will be equal to t, and negative 3t plus 120 will also equal to t, right? So here we have t is equal to 10, or t is equal to 40, right? So we have 2 answers here. So how can we know which one is right? So let me just write it here. So if time is equal to 10 seconds, Then we know the formula that final velocity is equal to initial velocity plus acceleration times time. So in this case, acceleration is a negative number, so it will be represented by a negative sign here, right? So if time is equal to 10 seconds, then the final velocity will be equal to the initial velocity is 15 minus 0.6 times 10, which is equal to 15 minus 6. So it is equal to 9 meters per second. And if time is equal to, let me write here. If time t is equal to 14 seconds, then final velocity will be equal to 15 minus acceleration 0.6 times 40, which is equal to 15 minus 24, which is equal to negative 9 meters per second, right? But in the problem, we know that if the final velocity is negative, then what happens is that let's say this is a picture, right? So here is 120 meters and move up with an initial velocity of 15 meters per second. But however, if the velocity here is negative 9 meters per second, then the car will slide down, right? So we know the velocity must be a positive number. So because here the VF is less than 0, so it is the wrong answer. So 9 meters per second is the correct answer, right? So we know that then t must be equal to 10 seconds, because when t is equal to 10 seconds, the final velocity is equal to 9 meters per second, right? So just let me write this down. So t is equal to 10 seconds, right? This problem is a little bit tricky, so just you really need to think about the condition when the car reaches the top, right? So let's solve for the second problem. Let's give us more space, right? So a car slows down at a constant acceleration by pressing on its brake until it stops. So final velocity is equal to 0 meters per second. Given that the average velocity for the half journey is v, what is the average velocity for the second half journey? So this one is a little bit trickier. So let's just underline some really important information. So the first one is constant acceleration, right? So for this problem, I am gonna draw a picture first. So assume this is a starting point A, and then this is the end point B. Then because it's half journey, so I'm gonna draw a midpoint C, right? Press on it. So this picture is a hint. So pause the video and think about this question by yourself first. Alright, so now I'm going to do it. So it says the average velocity for the first half journey is v. So I'm just gonna row VA at point A, VB at point B, and VC at point C. So we know average velocity v must be equal to VC plus VA divided by 2, right? So this is the average velocity. Then what else do we know? Well, we know the final velocity is 0, so VB must be equal to 0 meters per second. Then we can solve for the average velocity in this part as well, right? So the average velocity in this part must be equal to VC over 2, right? Because it's plus 0. right? Then then what can we do is that because this problem does not give us a lot of information, so we can just play around with this problem, right? So this is half journey, so I'm just gonna set here s over 2, and here is also s over 2, right? So let me just restore. So s is the total distance, right? Then what else do we know? Well, if here we know the distance, we also know the average velocity, then we can know time, right? So time take A to C is TAC, and time take C to B will be TCB, right? So the total time will be TAB, which is equal to TAC plus TCB, right? And we know TAC will be equal to s over 2 divided by v is initial velocity, and TCB will be equal to s over 2 divided by vc over 2, right? Then what else can we do? Well, can we know the average velocity for the whole journey from A to B? Yes, we do, because VB is equal to 0 meters per second, right? So VAB is equal to VA plus VB divided by 2, which is equal to VA plus 0 divided by 2, so it's just equal to VA plus 2, right? VA over 2, I mean. So TAB will be equal to S over VA over 2. Well, now we can express this equation in terms of all of those equations we have just listed off. So let me write it here. So the first thing we know is that VA, let me use another color. So the first thing we know is this one, right? And then we also know this formula. So let me just write this down here. So V is equal to VA plus VC over 2. And TAB is equal to TAC plus TBC, which is equal to S plus which is equal to S over 2 divided by S over 2 divided by V plus S over 2 divided by VB over 2, which is equal to S over VA over 2, right? So all of those is just so this formula come from here, and this equation come from here, and this one come from here, right? So now we know two really important equation. So let me just rewrite this. So V is equal to VA plus VC over 2, S over 2 over V plus S over 2 over V B plus 2 is it, oh wait, I think it's VC here. Hold on. Oh, here's VC, sorry guys. So here's C. I copied that wrong. Is equal to S over VA over 2, right? And now we can just solve for this two variable equation. So this one will be equation 1, and this one will be equation 2. So from equation 1, we know that we know that VA is equal to 2V minus VC. So let's simplify equation 2 first. So here, as over 2V plus, here we can just divide it by 2. So as over VC is equal to 2S over VA, right? So it's equal to 2S over VA. And then we'll just cancel all S. So the equation becomes S over 2V plus, 1 over 2V plus 1 over VC is equal to 2 over VA. So now let's plug in this formula. So this will be equation 4, and this one will be equation 3. So plug equation 3 into equation 4, and it becomes like this. Right? So this now looks much better because we only have 2 variable. And then let's simplify this. So to combine those 2 fractions, so 2V VC plus 2V is equal to 2 over 2V minus VC. Well, now I'm just gonna use cross multiply. So 4V VC is equal to 2V minus VC times VC plus 2V, which is equal to 2V VC plus 2 4V squared minus VC squared minus 2V VC. So this 2 term cancels out again. So 4V VC is equal to 4V squared minus VC squared, right? Well, what can we do right now? Let's think about this a little bit. Let's think about it. So now this is a little bit confusing because there's a lot of algebra here. So let's just go back to this question and think about what the question is asking for. So it's asking for the average velocity for the second half journey. So it's asking here, right? Average velocity for the second half journey. Well, how can we solve for it? So here it says the average velocity is gonna be equal to VC over 2. So it seems like as long as we know VC, we know the answer, right? And what we have right now is this confusing equation. So how can we simplify this even more and solve for VC? Well, this seems like another quadratic function. So I will just move, this time I will move those 2 terms into this side because here it has a negative sign. So VC squared minus 4VVC, plus minus 4V squared is equal to 0. So now this has become a quadratic function. So just in case if you forget what quadratic function is, so ax squared plus bx plus c is equal to 0, and c is a constant. So x can be solved by the formula of 2a negative b plus 1 minus the square root of b squared minus 4ac, right? And in this part, we want to know vc, right? So here 4v will be the b, and here 4v squared will be the constant c. I mean this whole thing, negative, including the negative sign. So let's solve for it. VC is going to be equal to 2 negative 4v plus 1 minus the square root of, so the square root 4v squared, so 16v squared minus 4 times negative 4v squared. Right? So let's check if there's any arrow. So negative 2. Alright, it seems like everything is correct so far. So plus 1 minus. So here is negative 2v plus 1 minus. So here it will be 32v squared. So you just simplify, and then it becomes 16 times 2, 2 times square root of 2, so 2 times square root of 2, and then the factor the v out, right? So take away the common factor, so 2, so here's gonna be a negative v plus 1 minus v times square root of 2. Right, so how do we deal with the plus and minus thing? Well, we know here is negative 2v, and if here is a negative sign, so if it is negative 2v minus 2v times square root of 2, then the whole thing will be definitely less than 0, right? Well, then we can look back to our question. So what is the average velocity for the first half journey, right? And we know the car slows down until it stops, so final velocity gotta be equal to 0 meter per second. So if the velocity is going to be negative, it will move back, which is not what the question telling us, right? So go back to this equation. We know here BC gotta be greater than 0, right? So here gotta be a plus sign, so plus v times the square root of 2, right? And then we can just take the, here gotta be plus. Then we can take this negative sign away. So I mean take the v away, sorry guys. So 2v negative 1 plus square root of 2. So this is vc. And we know the average velocity is equal to vc over 2. So you just simply divide it by 2, which is equal to v times negative 1 plus square root of 2. So this will be your final answer. This equation right here. This is your answer. This question is this is a tough question because it does not only involve physics, it also involve a lot of math. So you definitely wrote a lot here. So now let's go to the next problem. a tree moves forward at a velocity of v1, the driver suddenly realized that at a distance of s, there's another train moving at the same direction with a velocity of v2. To prevent any accident occurring, the driver immediately let the train slows down at a constant acceleration of a. What volume should a be if the two trains do not collide? Well, let me draw a picture here. So this is train 1, and then train 2, right? Oops. And this one is moving at a velocity of v1. This is moving at a velocity of v2. So what will happen if they collide with each other? What's gonna happen? So let me draw a more clear picture here. So let's say this is the total distance they travel, right? So this is gonna be s. What happens if they collide with each other? What would happen if they collide with each other? Well, so just let me draw a more clear picture here. So I'm gonna erase all of those. So at distance s, there's another train moving at a velocity of v2. And here, there's a train 1 moving at a velocity of v1. So think about what would happen if two trains they collide with each other. How would you solve this problem? So moving at the same direction with a velocity of v2, well, if those two trains collide with each other, so this train here will still keep moving, right? If they collide with each other, here's gonna be train 1 and train 2 as well, right? So here train 1 will travel a distance of s plus another extra distance x, right? So if we know x, we can list a formula here, right? We can not formula, I mean list a equation here, right? So if they collide with each other, let's say here is x, so s plus x must be equal to the total distance traveled by train 1. And for x is traveled by both train 1 and 2, right? So we can we can express this image in terms of mathematical equation. So I really need some space, so let me do it here. So let me just redraw this picture. So this is train 1, this is train 2. And if they keep moving, right? So here is s, and here will be x. How can we express x? Well, we know tray 2 is moving at a velocity of v2, and tray 1 is moving at a velocity of v1 with a acceleration of a. And we also know that this distance here, so x, is traveled by both tray 1 and tray 2, right? And tray 1 and tray 2 have the same amount of time. So since tray 2 start moving here and index here, then this part x will be the total distance traveled by tray 2. So how can we express this? Well, this is very simple, right? You can just so average velocity times time is equal to displacement. So now you know the equation for x, and then how can we express s plus x? Well, we also know x plus x is the total displacement for tray 1, and we can express them by using the formula of initial velocity times time minus a half times acceleration times c squared. Here's a negative sign because acceleration is a negative volume, right? So this can be how we express them. So let's just roll them together. So v2 plus t plus s must be equal to oh shoot, what is this? Let me change the color actually. So v2 plus times t plus s must be equal to v1 times t minus a half times acceleration times c squared. So this is what happens if they both collect, right? So and we are solving for time t. So this looks like another quadratic equation, and we definitely know how to do it, right? So you're just gonna move this term into another side. So 0 is gonna be equal to negative a half times acceleration times t squared plus v1t minus v2t minus s combined left term plus v1 minus v2 times t minus s. But this is what happens if they collect. But the problem is we do not want them collect. So, oops. If we do not want them collect, then there's no solution for the equation. For this equation here, right? So there's gonna be no solution for it. So while no solution, we know that delta gonna be less than 0. So delta is also equal to if ax squared plus bx plus c is equal to 0, delta is equal to b squared minus 4ac. So delta is equal to b1 minus b2 squared minus 4 times negative a half times negative s. Right, so let's solve this equation. So acceleration. Oh, here also I left a acceleration. v1 squared minus 2v1 v2 plus v2 squared. So here 2a and negative 2as. Oops. Here should not be. Oh. Less than 0. Now you can just actually you don't even need to simplify this equation. That's just doing extra work. So v1 minus v2 squared minus 2as is less than 0. So v1 minus v2 squared is less than 2as. So a must be greater than v1 minus v2 squared divided by 2as. So this is the answer for this problem. Another hard problem. So let me write the answer here. So a must be greater than v1 minus v2 squared over 2as. If I copied that correctly. Yeah, I did. Alright, now let's do question number 4. So a car departs from a place and moves with a constant acceleration of a. When the velocity reaches v, the car moves at a constant velocity for a period of time. Then the car decelerates at a constant volume of a2 for another period of time until is stopped. Given that the total distance traveled is s, what is the total amount of time the car traveled? Here moves a constant acceleration of a, reaches a velocity of v, and then move the constant velocity, so move at v for another time period, and then decelerate. So pause the video and try to solve this problem by yourself first. So now I'm going to do it. So the first thing I did is I draw a picture. So this is where the car starts to depart, and then it moves for a time period, and then travels at v for another time period. So here is also v, and then it decelerates until the velocity is 0 meter per second, and here is also 0 meter per second. So and we know the total distance is s, right? So what I did is I separated the question into 3 parts. So here is T1, T2, T3. And here is S1, S2, and S3. Well, and there's 2 ways of solving this problem. So the first way is a little bit involve more step. So T1 is equal to v minus 0 divided by a, which is equal to v over a. So T3 is equal to 0 minus v over a2. So T3 is equal to 0 minus v over a2, and then to take the absolute volume, so it's equal to t over a2. So now the only thing we need to know is t2. We also know the total distance traveled by the car is s. So s is equal to s1 plus s2 plus s3. So s1, we know the initial velocity is 0, so it can be equal to a half times a1 squared plus s2 plus here the velocity is v, and we know we can also know the final velocity is 0, so we can know the average velocity, right? So v plus 0 over 2 times t3, which is equal to a, because we don't want a t1, because this is what we are solving for, so we are gonna plug in this equation here. So v squared a squared plus s2 plus v over 2 times t3, so v over a2, which is equal to, so here cancels out, so a half times v over v squared over a plus s2 plus v squared over 2a 2a2, which is equal to s, so s2 is equal to s minus 2a, here is v squared plus 2a2, here is v squared as well. So this is s2, right? So we know s2 has a constant velocity. So time can be calculated by using s2 over v, so which is equal to s minus v squared 2a. Here should be minus actually. Minus v squared over 2a2 over v. We are running out of space, but that's okay. So s over v minus, so here this v and this v cancels out. So v over 2a minus v over 2a2, right? So this is s2. Actually this is t2, sorry. So this is t2, and we also know t1. So let's see. So we know that the total time, so total time is equal to t1 plus t2 plus t3, which is equal to v over a plus v over a2, and this thing right here, so plus s over v minus v over 2a minus v over 2a2, right? And then you just combine the fraction together, so 2a here, 2av combined with this one. So now we're just gonna combine different equations. So here 2a 2v minus v plus 2a2 2v minus v plus s over v, so v over 2a plus v over 2a2 plus s over v. So this is equal to time. If you want, you can combine those equations, combine those fraction. So let me see. Yeah, so this will be the answer. Right. Oops. Now let's do problem number 5. A car moves in a straight line with a constant acceleration and passes point A, B, C. Given that AB is equal to BC is equal to S, and it takes a time of t1 to pass AB and a time of t2 to pass BC. What is the acceleration for the car? So for this problem, I'm gonna draw a picture first. So here is point A, point B, and point C, right? And we know it has a displacement of s, and takes a time of t1 for A, B, and takes time of t2 for B, C, right? And what else do we know for this problem, or what can we know from the information we are given? Well, it seems that we only know two things: the distance the time, and another thing is a constant acceleration, right? But for displacement and time, we can know the average velocity. So average velocity for AB is equal to S over T1. And average velocity for BC is equal to S over T2, right? So where is velocity AB and velocity BC on the picture? Well, because it has a constant acceleration, so the average velocity must be in the middle here. So if it is in the middle, here must be S over 2. So here is VAB, and here must be VBC. And here is also S over 2. And for the time, here must be T1 over 2. And here is also T1 over 2. And here must be T2 over 2. And here also is T2 over 2. Why is the velocity in the middle of the line? It's all because it has a constant acceleration, right? So I will draw a motion diagram to explain this. So here we have our graph for velocity versus time, right? So here, let's say here is our final velocity, and here is our initial velocity. So here is our triangle, and our average velocity is here. Right, and time is here. So we know those two lines are equal. So those two lines are equal. Right? So if here is x, here must also be x. So here must be 2x. And we also know those two must be similar triangle, right? Because here they all have the same angle, right? So let's say here is theta, then here must be 19 degree minus theta, and here also must be 90 degree minus theta. So if this is a similar triangle, and here, so let me just draw this triangle again. Oops. So here, if here is a big triangle, and here is x, we know, let's say this line here, right? So we want to know if those two lines are equal. Well, because here those two lines has a ratio. Those two lines has a ratio of 2x over x with over x, which is equal to 2. Then here, those big line to the small line must also has a ratio of 2 over 1. So if here is y, here must also be y, right? Then the total length will be y. So those two lines, let me change the color. So those two lines must be equal. So if so let's go back to the picture. Here, the x-axis will be time, and those two lines are equal. It means that here, if this time is t1, here is also t1, right? So the average velocity must be in the middle of the graph, right? So that's why the average velocity is in the middle. So let me just go back here. So we know the average velocity here. We also know it must be in the middle of the graph. Then how can we solve this problem? Well, so here's what we can do. So let me erase something. Let me just redraw the picture a little bit. So here, point A, point B, point C. Here is the average velocity. So VAB, VBC, time interval T1 over 1, TO over 2. Here is T2 over 2. We also know it has acceleration of a constant acceleration here. So if we say the big time interval here is delta t, right? So then we know that VAB plus acceleration times time interval times delta t must be equal to VBC. And delta t is equal to T1 over 2 plus T2 over 2, right? So we can also express delta t in terms of T1 and T2. Then what about the acceleration? How can we write acceleration in terms of the condition? We already know. Well, so here, let me just rewrite this equation a little bit. So average velocity VAB, we can express them in terms of S and T1. So S over T1 plus acceleration times T1 over 2 plus T2 over 2 is equal to S over T2. Now what we need to do is we just need to solve for A, right? So we only need to know this quantity. So S over T2 minus S over T1 divided by T1 over 2 plus T2 over 2 is equal to acceleration. So just combine those fractions. So here is T1. T1, oops. T2 as T1 minus T2 over T1 plus T2 here, A. So this part will go down and the 2 will go up. So S times T1 minus T2, and then the 2 will go up, so 2 over T1 T2 times T1 plus T2. So this part here is the answer for this problem. Alright, so let's just look back to the problem. So one important thing for the problem is you have to think one way to visualize the problem a little bit so that it is easier for you to solve the problem. And I know for the average velocity here might be a little bit tricky. So if you don't know how to do it, just draw a diagram and solve them algebraically. Cool. So let's go to the next problem here. So two cars depart on the highway at the same time in the same direction. The initial velocity for car A is 10 meters per second, and the initial velocity for car A presses its brake to decelerate onto its stop. So final velocity of 0 meters per second. The deceleration has a magnitude of 4 meters per second squared. The initial velocity for car B is 0 meters per second. And it decelerates with a volume of a meter per second squared. How long does it take for the car to process B? So for this problem, the first thing I pop in my mind is I need to calculate the displacement for car A and car B. And if car A passes car B, then the displacement for A must be greater than the displacement for car B. So now you just need to find an equation for those two quantities. Well, what do we know? We know the initial velocity for car A, we know the final velocity for car A, and we also know acceleration for car A. So, which kinetic formula pop in your mind? Well, acceleration for car A can be equal to initial velocity times time minus a half times acceleration times t squared. And this is what we are solving for, right? Time. So 10t minus a half times 4 times t squared. So this is for car A, and for car B, same thing. Oh, accelerate, sorry, accelerate. So here should be a positive sign. And you know, xa is greater than xb, so 10t minus, so here is equal to 10t minus 2t squared. So oops. Oh, shoot. 2t squared. Oops, sorry, I forgot to. I plug in the volume for A, so here it should only be positive. So there's no A anymore. So a half t squared. So just let me erase this equation and rewrite it real quick. Minus 2t squared is greater than a half t squared. So I'm just gonna multiply both sides by 2 because I don't really like fraction. So combine the log term. Divided both sides by 5. No, here, here. Sorry, guys. So t must be greater than 0, and where t must be greater than 4. Actually, here should be and. So why do I write and here? So if the quantity is greater than 0, then here must be positive, and here must also be positive, right? Or here can be both negative, and here is also negative. But we know for time it must be a positive quantity, so I do not consider the second case. I only consider the first case. So from those two, we know t must be greater than 4, right? So if you don't know why, just draw a number line. So t must be greater than 0, and t must be greater than 4. So here is a solution of t must be greater than 4. Well, is t is greater than 4 actually the answer? No. Why? Because it says it decelerate until it stops. So we need to check if the solution is correct, right? Because it might have a negative velocity, so the car is running back, which is not the case for the problem. So we need to check the answer for t is greater than 4. So let's check the answer. Let me just roll it here. So if t is greater than 4, what is the velocity here? So Bf will be equal to 0 minus acceleration is 4 times 4, which is equal to negative 6 meters per second. So which means that is not the answer, right? Because the velocity becomes a negative quantity, so it must not be the answer for our problem. Then how do we solve for the problem? So to solve the problem, let's just calculate the actual displacement for A, right? So let me write KA2. So we know the initial velocity, we know the acceleration, we also know the final velocity. So VA0 plus VAF over 2. Actually, we cannot use this formula. So let me do this. So here is 0 is equal to 100 plus, here should be a negative number, so negative A times SA2. So negative A SA2 is equal to 100. SA2 will be equal to 12.5 meters. So it's 12.5 meters. Then we can calculate the time. So TA2 is equal to VF minus V initial and take the absolute volume. So here is 10 over 4, I think. The initial velocity. What is the initial velocity? Initial velocity is 10 meters per second. And final velocity is 0 meters per second. Change in velocity is also 10 meters per second, and so for here is 0.5 second. So after 2.5 second, car A stop. Then what about car B? Well, we know, this quantity is how much car A travels, and for if car B wanna pass car A, it must also travel this distance, and after this distance, car B will pass car A, right? So let me draw a picture. So this is car A, and here is 12.5 meters. So car A moves, and car B also moves. But here, after 12.5 meter, car A stop. And so let's say car B is here. So as long as it passes 12.5 meter, it passes car A. So how much time does it take for car B to travel 12.5 meters? Well, we know it has an initial velocity of 0 meter per second, and acceleration of 1 meter per second square, and what else do we know? And we also know the displacement for car B must be equal to 12.5 meter. So we can use the formula of a half times acceleration times t square, right? So 12.5 meters is equal to a half times 1 times t square. So 25 is equal to t square. So take the square root, t is equal to 5 seconds. So here is our answer for the problem, right? So this problem is a little bit tricky because you have to check for the answer of t is greater than 4. So let me just rewrite this answer a little bit so t greater than 5 seconds. Let me write it in this way. So after 5 seconds, car B passes car A. So let me just circle this. So this is your final answer. So I know the sixth problem in this video is a little bit tricky, but I think all of your guys can learn a lot from those problems, and I hope you find this video helpful. So again, thank you for watching, and please subscribe my video if you like it, and also you can follow my website. I will post a link in the description box.